All right, we're back. We're on page 197, math analysis. We're talking about parametric equations. We've talked about all the conics. And now what we want to do is kind of like revisit line segments, basically, but we want to do it in a different way. So what we're going to talk about is stuff that moves back and forth. And I love this. I love the ability to do this. I actually just did it, right? Back and forth, back and forth. That's what we're going to try to do. So we're going to talk about making round trips rather than going just from A to B. We're going to say, make a round trip from A to B and back again, or just a round trip between A and B. So you need to kind of understand what that means, but now I think you do, hopefully. So let's see if we can work out how to do this. We have to make a couple of assumptions because our abilities are a little limited at this point, but it's okay. The assumptions are gonna feel, I think, kind of natural. So we're gonna go from A, which is at -5,8. So I'm just gonna plot that, say this is like, -5,8, and it's A. So we're gonna go from there to 1512. So 1512 would be like here, let's say 1512, that's B. And we're making, so the first thing we're gonna do is we're gonna start at the point A. It's gonna take 40 minutes to make a round trip, which means, you know, you're here at 0, and then you go boom, boom, and that all takes 40. So here to here and then back takes 40. So what the assumptions that we're going to have to make are that we get to B halfway through. So if we're here at t equals 0, we're going to be here at t equals 20. And then we're going to be back here again at t equals 40, because that's a round trip. The other assumption we're going to make is that we actually get to the midpoint. So let me put a line here. We're going to assume we get to the midpoint at the midpoint of each part of the journey, right? So if it takes us from 0 to 20 to get here, we're going to say that we got here at first t equals 10. And then if it's from 20 to 40, we're going to say we get back here at t equals 30. Now, once we've done that, we can pretty much answer this question, I think. The midpoint will be -5 plus 15 is 10 divided by 2, so that's 5, and then 8 plus 12, it's 10, is the midpoint. You can just look at that. All right, so let's think about what happens. So let's focus on the x, right? So we need a grid, and we're going from -5 to 15 here. And then we know that this will be 40, 20, and then there and there. And it's -5, and then 5, and then 15. Okay, so we start at -5. Or you could just think x starts at the minimum, right? There's 3 x values, -5, 5, and 15. It starts at the minimum. What type of trig function starts at the minimum? It's negative cosine. This is going to be a negative cosine. So we're going to be here, and then we're here, and then at t equals 20, we get to 15, get back, get back. So we knew it would be negative cosine, but we did it anyway. So we get that. That is not a super great graph. I don't know, shaky fingers there. The period of this thing is 40, which is 2 pi over b. So b is going to be pi over 10. So our equation here is going to say that x is, so it's sinusoidal axis, bad 5, I think. 5, it's -10, and then cosine of pi over 10t. And then we do the same thing for y. Or you can think that y is also starting at a minimum. So this is kind of interesting. So I'm going to do y that way instead of graphing the component. So this was x and t. For y, I'm going to say start at min. Therefore, negative cosine. So y is going to be the sinusoidal axis. 10 is the middle point, and then -10. No, -2. What are you doing? -2, because that's how far you can go, right? You're at 10, you can go 2 up, you can go 2 down. So we're going to say that cosine. Now, are you surprised that we use cosine twice? I don't know. So our parametric equations are going to be, wow, that's all right. It's not all right, it's bad, but 10 cosine pi over 10t, and then 10 minus 2 cosine pi over 10t. All right, so were you surprised that you used cosine of pi over 10t twice? I think you shouldn't have been. And the reason I think you shouldn't have been is if we wanted to eliminate the parameter here, I would say from here that x minus 5 over negative 10 is equal to cosine of pi over 10t. And then I would say from here that y minus 10 over negative 2 is also equal to cosine of pi over 10t. And then, since they're both equal to cosine of pi over 10t, we can say, therefore, x minus 5 over negative 10 equals y minus 10 over negative 2, which is a line. And I knew it would be a line because they're traveling in a line segment. By the way, you can actually do this with a circle. You could make it so that, because it doesn't stipulate you go through this midpoint or anything, you could actually make a circle that kind of like does this. It's not the intention of the problems, but it would have worked. But I wanted a line, so it worked. And that's pretty cool. So should we, you know what? I'm gonna cut it here. I'll come back in the next one and do the next two because I feel like they'll go faster. I don't really know. You know what I could do? I could do this in GeoGebra while we're here. Let's just do it really, I always say really quickly, but I probably never really mean that. Because you should always be doing things in GeoGebra, especially the parametrics, like so good. I can't believe that it's free. Like it blows my mind. Curve 5 minus 10 cosine pi over 10t, comma 10 minus 2 cosine pi over 10t, comma t. Now I need to go from 0 to 40 is what I need, like to make this happen. I'm not seeing anything, but is that because I just can't see it? Yes, I think so. Okay, how do I put the endpoints on this? Definitely a of 0 will give me one endpoint. But what gives me the other? Remember, it's a round trip takes 40. So instead of doing a of 40, which is going to put me in the exact same spot, and you can see now I have 2 overlapping points, which I didn't want, so I'm going to delete that. It's a round trip. So if it takes 40 for the whole thing, it takes 20 to get halfway across. So a of 20 should give me, what is this? Why are you doing this to me? It takes 40. Oh, look at that. So my equations are actually wrong. This should be 20, and this should be 20 because I had it wrong. So look at that. Okay, now a of 20 is doing it. I got to go back to the notes and fix that. Let's put a point on this. A of v. This is it. This is why we always want to do it in GeoGebra, so we can check it and fix it before I move on. You probably already moved on though. And let's make the motion. Why are we going from 1 to 40? Like honestly, 0 to 40. Go back to 0 and motion. It's gonna like slow down, stop, turn around. It's speeding up. It's gonna start slowing down, stop, turn around, and it's just gonna keep going forever. So we did it. I gotta go back and fix that. I think I see the mistake. Well, I know what the mistake. You probably also saw the mistake when I made it. I imagine everyone's just screaming like, change it, change it. It's right here. Actually, it's all over the place. Crud. It's all these, every one of these denominator 10s. That's it. That's where I made the mistake. 10, 10, 10. All right, they're all going to be in red now because I'm fixing it. So these are 20s. 20, 20, 20, 20. Thwarted by like very basic division. So that's sad. Anyway, I'm going to stop this video here now and come back in the next one and finish this page, hopefully. So I will see you there.